Hi, today I want to show you a set of camera stands I built for documenting my projects. My main goal was to have a setup that interferes as little as possible with my workflow. I wanted something that could stay out of my way, yet be ready to capture whatever I'm doing on the bench or at the machine. The main problems I ran into were getting different shots framed quickly as I moved between machines, being able to do overhead shots with enough distance from the work surface, and having a set and forget setup that could run for hours without running out of battery or SD card space. At first I used a regular tripod with a USB power bank, but that setup turned out to be pretty cumbersome. The tripod legs were always in the way, and repositioning took pretty long. I also tried mounting the camera on a measuring stand with a magnetic base and an articulated arm. It worked surprisingly well. Most surfaces in the shop are metal, so I could just stick it wherever I needed it. The notable downsides here were the limited height, and there was not really a good place to mount batteries and wireless transmitters. On top of that, this would not work universally as there are some wooden tables here, and the surface plate is made of granite. Taking what I liked from that version, I came up with the design I'm showing today. This stand features 100 watt-hour battery with a built-in BMS and an USB-C charging circuit, a vertical rod for height adjustment, and an articulated arm for flexible positioning. It also has an intentionally heavy base, which allows a large overhang even with fairly heavy cameras. Overall, it's a compact, versatile setup that can sit idle for hours, ready to capture whatever I'm working on without getting in the way. Let's build it. I started by printing the outlines of the base plate, including the hole locations. If you do this, I recommend dropping at least one dimension in the drawing to make sure the print is properly scaled. After gluing the template to a steel plate, I center punched the needed hole locations first. And then use the bandsaw to cut the shape out. Next, I drilled and countersunk the needed holes using the previously made punch marks. To move the center of gravity back, I welded a small container from sheet metal that I'll fill with lead later. The difference in plate thickness made the welding a lot trickier than I expected, but it worked out in the end. I also tacked on a small ledge for mounting the batteries. With the base basically done, I made the vertical bar, just a quick round of cutting, facing, center drilling, countersinking and tapping. For mounting the articulated arm to the center rod, we need a clamping block. After facing, we give it a simple profile and a circular pocket. Both with a finishing pass. With this simple first operation done, we turn the part around and face the other side to get it to final dimension. Off camera, I put two M8 threads in the part for the articulated arm and to clamp to the central bar. With all mechanical parts done, I soldered the parts for the internal power bank together. It was mostly following the schematics the seller provided with the BMS. The USB charging board was positioned to be reachable through a 3D printed housing. This board was also slightly modified to fit under the batteries by removing some unneeded components. I used two 3S LiPos from an older project wired in series. After confirming that everything worked as intended, I soldered a plug on the power leads and assembled the stand. Up to this point, both systems were mainly identical. From here, they deviate quite a bit. The first one just has a camera and an HDMI transmitter. What I like here is the really minimal cabling. It's really clean. For powering, I have a DC to DC converter for the camera, but for the transmitter, I needed a USB charging board. For some reason, just giving it straight 5 volt didn't work. So, in general, this transmitter is really solid, has relatively low latency, few hundred milliseconds maybe, and yeah, it's really stable. I used it for a few hours now, and the 100 watt hours, or about 100 watt hours the system has, works for hours, like 10, 12, and it still had some left. I don't actually know what's the maximum. There's one drawback on this system, and that's that the wireless transmitter stops working as soon as I leave this place. I do have access to 2 other facilities here, and I would kind of like to use this camera there as well. So I could use an SD card and just not transmit live, but I kind of want the safety of having data directly stored to the NAS. On top of that, I might forget at some point and just fill up the SD card and then lose data, or the SD card just breaks. It's just stuff that I don't like. I kind of want this direct feed. So yeah, that's the first one. The second one experienced quite a bit of feature creep. At first, I just wanted to try using a Raspberry Pi 4 for streaming the feed directly over the Ethernet. We have quite a good Wi-Fi here, so that would work everywhere, not just in this hall at all. That didn't work out. With no hardware encoding at all, the Raspberry Pi is just not powerful enough to do that. I looked a bit on the internet and I found something called the Radza X4. This is a Intel N100 based SBC that is technically more or less the same size as a Raspberry Pi. Really, it's quite a lot bigger if you think about it needing an actual heatsink. In this case, I used the old 1U server heatsink that was slightly modified to fit this board. With the hardware done and Linux installed, it turned out the system was quite snappy. It had no problem streaming at all. So in the end, I added a display on top of that and thought about what else can we do with that now. And for example, having a datasheet open while debugging some software or hardware issue might be very handy. And even better, the system is absolutely powerful enough to host a remote desktop connection to the bigger computer that actually captures the images. This allows us to start and stop the recording or monitor other or go into SolidWorks while we are working and looking for some dimensions. SolidWorks, really not made for a touchscreen, but in principle, it does work. You might have noticed that I didn't show you this camera actually working yet, and that is because at the moment it doesn't. After installing the system, it worked quite fine. It actually was really nice. But after a while, the HDMI to USB adapter that I'm using is just not recognized anymore. It is not the hardware of the adapter, and every other computer I have, it works fine, even with exactly the same cabling I'm using here. So there's something wrong. I don't exactly know what. With all that said, did we reach our goal? Kind of, and not so much, depending on which point you're looking at. For one, the mechanical design I do like very much. It really doesn't want to fall over at all, and actually holds quite nicely as well if you actually screw it down. But yeah, it works really good. On most of the usual surfaces, it's really nice. Even on a mill or lathe, it works fine. There are a few machines where the work table of the machine itself is too small or it doesn't really have one. For that, I actually got the tripod back, put a plate on it, so you can just put the stand on the tripod, and with that, you have a really fast way of placing it somewhere, and the versatility of the stand with the overhang gives you really nice shots. And now, 2 short examples of shots captured with this, so you can decide on your own if this hassle is worth it. I think that's that for this project. Thank you very much for watching. If you made it here, you probably at least somewhat liked this, or more probably you know me and I bothered you to watch this and give me feedback. Nonetheless, if you do have feedback for me, please leave it in the comment section. I would appreciate it very much. I'm new to this, and I hope you had at least a little bit of fun. Thank you very much.